I'm going to tell you something true that sounds like it can't possibly be real. There's a little tile, about the size of a postage stamp, not much thicker than a stack of a few coins, and you can set it right on top of a hot wood stove, a stove that's already burning, already throwing off heat you're doing nothing with. And that little tile will make electricity. No sun, no wind, no fuel beyond the fire you already lit. No wire running back to any power company. Just heat on one side, cool on the other, and current coming out two little wires. It costs about $15. Somebody with zero electronics background could put the whole thing together in half an hour. And the principle it runs on was worked out 200 years ago, and right this very minute, it's powering 2 spacecraft that left Earth before most of us were born, so far away now that their signal takes the better part of a day just to reach us. I've spent a long time around folks who live off-grid, who heat with wood, who genuinely believe in wasting nothing. And this is one of those tricks that, once you see it, you can't unsee the free energy sitting around you every single day. I remember the first time I actually saw one of these little tiles running on a hot stovetop, watching a cheap multimeter needle jump the second the heat sink started shedding warmth. It's a small thing, but it does something to how you see every fire you've ever built after that. You start looking at every stove, every engine, every pile of anything decomposing, and thinking, there's power leaking out of that right now, and nobody's catching it. I'm going to be straight with you right from the start, because that's the only way I know how to do this. This isn't some ancient homestead trick your great-grandfather used. It's a modern piece of technology, but it lives by about the oldest rule there is in any self-sufficient household. Waste nothing. Your stove's already burning. That heat is already pouring off it and going nowhere. This is a way to catch a little of what you're already throwing away and turn it into something useful, on your own terms, beholden to nobody. Catching a free thing nobody else bothers to catch. That's about as close to the old ways as it gets. Stick with me, because by the end of this, you'll know exactly what to buy, exactly how to put it together, and just as important, exactly what it will not do, because there's a lot of nonsense floating around about this trick, and I'm not going to be part of spreading it. Let me tell you where this actually comes from, because once you understand the history, the rest just makes plain sense. Back in 1821, a man named Thomas Johann Seebeck noticed something strange. When you join 2 different kinds of metal together, or later, special semiconductor material, and you make one side hot while the other side stays cool, electricity just appears purely from that temperature difference. No burning at the junction itself, no chemical reaction, no spinning parts anywhere. Hot on one side, cool on the other, and current flows straight across the gap. The bigger that gap between hot and cool, the more electricity you get out of it. That's the whole principle, and they named it the Seebeck effect after the man who first documented it. Now, for the better part of a century, that discovery mostly just sat on a shelf, because coal and later grid electricity were cheap, and nobody really needed a niche way to squeeze power out of a temperature gap. But then people who genuinely needed power in places where there was no power at all went looking, and they found it again. The Soviets, out along their frozen Arctic coastline, needed to keep lighthouses and navigation beacons running in places with no power line for hundreds of miles and nobody around to tend them regularly. So they built generators running on this same basic thermoelectric principle, though it's worth being straight with you. The heat source they used in a lot of those units was a radioactive material giving off steady heat through decay, not a campfire. That heat source part is genuinely not a backyard project, and I'm not going to pretend otherwise. But the part that actually turns a temperature difference into electricity, the trick itself, is the very same 200-year-old principle you can buy today for a few bucks. And then there's NASA. When the space agency needed to power spacecraft headed so far from the sun that solar panels stopped being useful out there, too little sunlight to matter, they turned to the exact same idea. In 1977, they launched 2 probes, Voyager 1 and Voyager 2, and to keep them running, engineers used this same thermoelectric principle. A hot side, a cool side, electricity generated purely from the difference between them, with no moving parts to ever wear out. Same honest disclosure here. Their heat source out in deep space also comes from a small amount of radioactive material decaying steadily over decades, which again is not something happening on your stovetop. But the conversion mechanism, the part actually doing the heat difference becomes electricity trick, is identical to what you're about to build for $15. And both of those probes are still out there right now, farther from Earth than anything else humans have ever sent, still phoning home, still running on nothing but a temperature difference, going on 50 years now, with zero moving parts and zero maintenance. So why isn't this sitting on a shelf in every hardware store next to the extension cords? Same reason as a lot of things like this. The grid got built, cheap power made most folks feel like they never needed to generate any of their own, and this particular trick got quietly kept alive mostly for spacecraft and military applications, and it just never made the jump to your living room stove. Not because it doesn't work, because there's no ongoing revenue in telling somebody that a $15 tile sitting on a fire they're already burning can catch electricity out of heat that was already going to waste. Nobody's sending you a monthly bill for that. Now here's the actual build, and it really is genuinely simple. But before I get into parts, let me clear up a couple things people get wrong constantly, because it'll save you money and frustration. First, this is not the same thing as a solar panel, and it doesn't compete with one on total output. A solar panel, even a modest one, will outproduce a handful of these tiles on a clear day, no contest. This isn't here to replace solar. It's here to catch energy solar can't touch, heat specifically at night in a cabin and weather solar panels do nothing in. Second, people see the word generator and assume it means loud, gas-powered, needs oil changes. None of that applies here. There's no motor, no fuel tank, no moving parts of any kind in the tile itself. It's closer in spirit to a solar cell than a gas generator, just reacting to heat instead of light. The main component is called a TEG module, a thermoelectric generator. It's that little tile I described, ceramic and metal, roughly the size of a large postage stamp. Inside it are dozens of tiny pairs of semiconductor material doing that same Seebeck trick. Hot on the bottom, cool on the top, electricity coming out two small wires. I need to flag one important detail here because this is the single most common mistake people make, and I'd genuinely rather you get it right the first time instead of buying the wrong thing. There are two kinds of these little tiles that look almost identical online, and people mix them up constantly. There's a cooling module. You'll often see it listed under a part number like TC1-12706, and that one was actually built to do the opposite job. It's meant to cool things down when you run electricity into it, not generate power from heat. It can technically make a trickle of electricity if you put a heat source on it, but it's not built to handle the sustained high heat of a wood stove for long, and it'll degrade and quit on you fast. What you actually want is a module built specifically to generate power from heat. A real TG, sometimes listed under a part number like SP1848 or similar naming, which produces meaningfully more electricity and is built to handle real stove-level heat over the long haul. So when you're shopping, specifically search for a thermoelectric generator module, or TG, not a Peltier cooler. That one detail is the difference between this working reliably for years and quitting on you within a week. The tile by itself only produces a few volts, which isn't really enough to do much directly. So you add one more cheap part, a small booster circuit, just a few dollars, usually with a USB port on it, that takes that small, unstable voltage coming off the tile and steps it up into a clean, steady 5 volts, the kind that'll actually run a standard USB cord. Tile plus booster. That's the whole heart of this build. Altogether, you're looking at somewhere around $15 total. Here's how you actually set it up so it performs well, because the entire trick lives or dies on that temperature difference. You set the TG tile flat against the hot surface of your stove. Between the tile and the stove, smear on a thin layer of thermal paste, the same stuff used inside computers to move heat efficiently between two surfaces, so heat transfers cleanly into the tile instead of getting trapped at a rough, uneven contact point. That's your hot side handled. Then, on top of the tile, you fasten a heat sink, one of those finned aluminum blocks, basically a little metal cone. Its entire job is to shed heat as fast as possible and keep the top of the tile as cool as it can manage. Remember the rule: the bigger the gap between the hot bottom and the cool top, the more electricity you generate. So you genuinely want that top side dumping heat as efficiently as it can. Even just ambient room air moving across those fins makes a real, measurable difference. Some folks aim a small fan across it for even better results. And here's a nice little detail: you can actually run that fan off the very electricity the tile itself is generating. Wire the tile into the booster, plug your device or your fan into the booster's output, and you're pulling usable electricity straight out of a fire that was already burning anyway. Now I want to be completely honest with you about what this actually does and doesn't do, because there's plenty of content out there that'll have you believing one little tile is going to light up your whole house. That's nonsense, and I'm not going to be part of spreading it. One small tile produces a modest, steady trickle of power. It is not running your refrigerator. It is not running your well pump. It is not powering your house. If a video ever tells you a $15 tile does that, close it, because that person's not being straight with you. What one tile genuinely will do is provide a slow, steady trickle, enough to top up small things over time. A radio, a lantern battery, a flashlight or headlamp, a small LED light. If you're out at a hunting cabin, it'll slowly charge a phone. Slowly, mind you, a genuine trickle, nowhere near the speed of a wall charger. It's for the small stuff, and for patiently topping things up while the fire's already doing its main job of keeping you warm. If you want more than that, here's what people actually do. You don't rely on just one tile. You wire several together, feed them into a slightly better booster circuit, and charge a small battery bank with the combined output. Put a handful of these tiles on the stove itself or clamped against the stovepipe. Run the wiring into a small battery, and now you're genuinely charging that battery every single time there's a fire going. That's enough to run LED lighting through a cabin in the evening, keep a radio and basic tools charged, trickle a bit into whatever's running a small pump. Still not your whole house. I want to be honest about that every single time I say it, but genuinely useful free power generated from a fire you were burning anyway, at exactly the time solar panels are doing nothing because the sun's down, and if you happen to be off-grid or the power's out from a storm, that trickle keeps matching. That's the honest picture. Modest from one tile. Genuinely useful from several. Never your entire house. Here's the part one actually like best about this whole thing. Once you understand the underlying principle, you start noticing free heat everywhere you look, and free heat sitting there unused is just electricity waiting to be caught. The wood stove is the obvious one, and honestly the best one for most people, because through a real winter, that stove's running practically all day and evening anyway. But think a little wider than that. Somebody running a work van or a camper. An engine throws off a genuinely enormous amount of heat while it runs, heat that just blows away and does nothing. Mount a tile against warm metal near the engine bay, and it generates a small trickle of power every single mile you drive. It's not replacing your alternator, but it quietly tops off your batteries the whole time you're rolling, with no solar panel needing to be aimed at anything. Out camping, a single tile with a booster fits right in a coat pocket. Set it at the edge of your camp stove or near your fire. The same fire you're already cooking supper on, fins facing up to catch the air, and you've got a slow charger running off a meal you were already making anyway. No separate battery pack to remember to charge before you left home. A hunting or fishing cabin used a handful of times a season, running a small propane heater or a wood stove. That heat's already there regardless. A small setup like this keeps radios, lights, and a GPS unit topped off across the whole season without hauling in spare batteries or running a noisy generator. And here's the one that surprises people most, and it might be my favorite of the bunch because it's the least obvious. A compost pile. A genuinely active pile of decomposing plant matter and manure gets legitimately hot inside as it breaks down. Hot enough to visibly steam on a cold morning while the outside air stays cool. That's a real, usable temperature difference. Set a tile right at that boundary, hot side facing in toward the decomposing material, cool side facing out, and that rotting pile will generate a small amount of electricity, enough to run a small sensor or a little light, off nothing but ordinary biological decomposition doing exactly what it naturally does. No fire, no fuel, no sunlight required. Just biology doing its own thing, and you catching a sliver of the energy on its way out anyway. Let me answer a few things people ask me constantly about this because it'll save you some back and forth in the comments. Does the tile wear out over time? Eventually, yes, but these things are rated for tens of thousands of hours of use under normal conditions. You're looking at years of daily use before you'd notice any real drop in output, not weeks. Can you run the tile directly on an open flame instead of a stovetop? Don't. These have a maximum temperature rating, and direct flame contact will exceed that fast and cook the tile permanently. Always mounted on a surface, never in direct fire. Does the thickness of your stove's metal matter? A little thinner stovetop metal transfers heat into the tile faster. But even a thicker cast iron surface works fine, It just takes a bit longer to reach a stable temperature difference after you light the fire. And one more. Do you need any electrical experience to wire this up? Genuinely, no. It's 2 wires from the tile into 2 matching input terminals on the booster, and a USB port on the other end. If you've ever wired a lamp switch, you've got more than enough skill for this. I want to take a second here because this next part is really the whole point, and it ties back to everything I actually believe about using what you've got. Think seriously about how much heat you generate and just let go to waste every single day. Your wood stove heats the room, sure, but a genuinely significant portion of its heat goes straight up the flue pipe and out the roof, completely wasted. Your cook stove, your vehicle's engine, your compost pile, every fire you build, every one of them produces far more heat than you're actually using, and the rest just leaks away into the air, gone already paid for, and wasted without a second thought. We've gotten so used to that waste that most of us don't even register it as waste anymore. Now think about what a utility company actually does for a living. It burns fuel, coal, gas, whatever, to generate heat, uses that heat to make electricity, sends it down hundreds of miles of wire to your house, loses a meaningful chunk of it along the way through pure transmission loss, and bills you for every remaining bit that arrives. Their entire business model is turning heat into electricity and selling it back to you. And here you are in your own home, generating real heat all winter long with your own stove, and throwing away every bit of the electricity that heat could have quietly handed you, simply because nobody ever mentioned you could keep some of it. That's really the whole point of this. I'm not telling you this little tile is going to cut you loose from the power company entirely. One tile absolutely will not, and I won't pretend otherwise. But it cracks the door open on a way of seeing energy that a lot of self-sufficient, waste-nothing households have always practiced, and that most of us have genuinely lost touch with. Old-fashioned wood-heated households wasted almost nothing. The heat off a cook stove warmed the kitchen, then warmed the water sitting on it, then warmed the room above through the floor joists. One single fire did 4 or 5 jobs at once. This little tile is just a modern way of doing that same old thing, squeezing one more bit of genuine use out of heat you already paid for, instead of watching all of it fly straight up the chimney while a separate check goes out every month for electricity that heat could have partly generated itself. So here's what I actually want you to go do. If you've got a wood stove, a hunting cabin with a stove in it, a work rig you drive regularly, or a compost pile going, order yourself a real TG module. The generator kind, specifically not the cooler kind, along with a small USB booster circuit. $15 for the pair. Grab a small heat sink and a bit of thermal paste while you're at it. Set the tile on your hot stove with the paste underneath it. Fasten the heat sink on top. Wire it into the booster and plug in a small light, a radio, or a charging cable. Watch it come to life off a fire that was already burning regardless of whether you caught any of that heat or not. Start small, with just one. Once you've actually seen it work with your own eyes and you understand the principle firsthand, then decide for yourself whether it's worth adding more tiles and a small battery bank to build something bigger. And hang on to the honest limit the whole way through. It's a trickle from one tile, genuinely useful power from several wired together, and never your entire house. Anybody telling you otherwise is selling you something. Tell me in the comments what heat you're currently wasting without even thinking about it. The wood stove, the cook stove, an engine, a compost pile. I read every single one, and it genuinely shapes what I dig into next. And if you actually build one of these, come back and tell me how it went, what you ran off it, how it held up over time. People who try this stuff and report back are honestly the whole reason I keep making these. Next time, I want to show you the old approach to getting the most heat out of the least amount of wood. How a stove gets positioned and a room gets arranged so that a single armload of firewood can genuinely carry a house through an entire night. It pairs naturally with everything I just showed you because it's really the same rule playing out again. Waste nothing. Until then, catch what you're already throwing away. Waste nothing.